Okay, so for question number 34, it says a 35 Newton force towards the west is applied to an object. The object moves 20 meters east during the time that the force is applied. What's the change in kinetic energy? That's a weird one. Yeah? All right, so let's list what we know first of all. So there's a force, and we'll draw a picture. So I have this object, and does it give us the mass of the object? No. All right. So let's just assume like we're going to go with like north, east, southwest. And so the applied force is towards the west. So we're going to do that. And what is that, 35 newtons? Huh? Oh, yeah. The west would be going this way. The motion is east, right? So it's 35 newtons westward, and that's a force. Okay? And then it's displaced 20 meters east during the time that the force is applied. So we have to make an assumption that the object is in motion. Yeah, so this thing's in motion to the east because that's the only way you can push westward and have this thing still going eastward. But it is displaced 20 meters this way. All right, cool. And then it says, what's the change in kinetic energy of the object? So now to find the change in kinetic energy, we're really looking for delta U, right? So, or delta K. So they're asking us what is delta K, right? That's what we need to know. What's the problem with finding delta K? So delta K is actually the final velocity minus the initial, not velocity, the final kinetic energy minus the initial kinetic energy, right? But the formula for that is 1/2 times the mass times the velocity squared, right? So what is that? Yeah, we don't know the mass, so we can't do that. We don't know the velocity, so we can't do that.
Yeah, we said it equal to mass.
Well, here's the trick. We know that delta K is equal to the work done. You guys know that? We know that delta K is equal to the work done. Right?
Over time.
Over time. No, it's just force times distance. Do we have a force? Do we have a distance? All right, so now here's what we got to decide. And this is where it gets tricky. What's positive? What's negative? Let's just do the numbers and we'll talk about how to do the positive or negative. So anyways, okay, so delta K is actually equal to the work done. And the work done is actually equal to the force times the distance. And so the force times the distance is 35 times 20. And if we multiply that out, that's 700. All right? Now, I'm not quite sure how you would want to label this. It works out a lot of ways to label it. If I make going to the right positive and going to the left negative, then my force would have a negative value. If I flip-flop that, then my displacement would have a negative value. In other words, if this is 0 and this is positive 20, I get, my displacement's positive, and then my force is negative because it's in the opposite direction. Now, if I were to reverse this and say that this was 0 and this was 20, either way, the force opposes the displacement. So I think we're always going to have a negative. Does that make sense? So I like to think of it like this. Negative 35 times 20, which would give me a negative 700 joules. Not too shabby.